All right, let's crack the code on computer networking. But we're not going to do it by just memorizing a bunch of facts. No, we're going to understand the story of how data travels, because that is hands down the best way to get ready for your CompTIA A+ exam. I mean, think about it. You type in a web address, hit enter, and poof, the website just appears. Well, it's not magic. It's this really fascinating journey. And by the end of this, you're going to understand every single step, which will give you that core knowledge you need to just ace your certification. So here's our game plan. We're going to follow one little piece of data, what we call a packet, on its adventure from your computer out into the wild internet and all the way back. We'll look at your local network, how you connect to the outside world, the rules that keep everything from crashing, the magic of Wi-Fi, and we'll wrap it all up with a cheat sheet to make sure it all sticks. Okay, our journey starts right here, at home, inside your office, in what we call a local area network, or LAN for short. The absolute easiest way to think about this is to picture your LAN as your own private digital house. So, take a look at this picture. Everything you see in that private section, that's our digital house. It's a trusted space where your laptop, your phone, your printer, they can all talk to each other directly, no need to go out onto the public internet at all. Right, great question. I mean, just like in the real world, every single device needs an address so it can be found. But here's the part that really trips people up on the exam. In the world of networking, every device actually has two different kinds of addresses, and they each have a very different job. On one side, you have the MAC address. Think of this like a permanent serial number or a social security number for your device's network card. It's only used for conversations inside your local network, inside the house. On the other side is the IP address. This is a temporary address, kind of like your mailing address. It's what the rest of the internet uses to find your entire house. The exam loves this distinction. So just remember, MAC is for local mail, IP is for global mail. So who manages all this local mail? Well, that's the job of the switch. You can think of it as the traffic cop or the internal mailroom for your LAN. Its entire goal in life is to look at those local MAC addresses and make sure a print job goes directly to the printer and not to your phone. Now, what makes a switch so smart is what you're seeing right here. It doesn't just shout the data out to every device. Nope, it learns. As you can see in this table, it creates a little map linking the permanent MAC address of each device to the physical port it's plugged into. This is absolutely key for efficiency. And this process is why modern networks are so fast. When your computer sends something to the printer, the switch creates this temporary, private line just between those two ports. Nobody else on the network even sees the traffic. It's like a direct, private conversation, instead of shouting across a crowded room. Okay, so that's great for stuff inside our digital house. But what happens when our little data packet needs to go somewhere that isn't in our local network, like a website halfway across the world? Well, it needs to leave the house, and that brings us to our next section. And this is the job of the router. If the switch is the internal mailroom, the router is the front door, the gatekeeper of your digital house. It is the single point of entry and exit, connecting your private LAN to that massive public network we call the internet. You will definitely see exam questions that try to trip you up on the difference between a switch and a router. Just remember our analogy. The switch works inside the house, the router connects the house to the outside world. But wait a second, this creates a really big problem. Your internet service provider, your ISP, they usually only give your entire house one single public IP address. So how can your laptop, your phone, and your TV all use the internet at the exact same time? The magic behind this is a technology called Network Address Translation, or NAT. And let me tell you, understanding NAT is a huge part of passing your exam. It basically lets your router act like a clever receptionist for your whole network, hiding all of your private internal IP addresses behind that one single public IP address it gets from your ISP. So our data packet has now successfully left the house, and it's traveling on the internet. But when the reply comes back to your router, how does your computer know if that data is for your web browser, or maybe your email client, or your online game? And the solution is just brilliant. Port numbers. If the IP address gets the data to the right building, which is your computer, the port number gets it to the right apartment, the specific application that asked for it. Every program that uses the network is listening on a specific numbered door. For your exam, yeah, you're going to have to memorize these key ports. But what's more important is understanding the why. Unsecure ports send data like a postcard. Anybody who intercepts it can read it. But secure ports, like HTTPS on port 443, use encryption. That's like sending your data in a locked box. Only the sender and receiver have the key. So far, we've imagined all our data traveling through physical cables. But what about when we cut the cord? Let's dive into the world of Wi-Fi and the technical standards you absolutely have to know for your exam. Trying to remember all those Wi-Fi standards like 802.11b, G, N, AC, and AX, it can be a total nightmare. So here is a fantastic exam tip. Just use this simple little mnemonic to remember them, in order, from oldest to newest. Be a great network architect. Let's break it down. B is for 802.11b, the original, slow, but it went pretty far. A was faster but had short range. Great is for G, which was the best of both worlds at the time. Network is for N, the first really modern Wi-Fi that used both radio bands. Architect is for AC, or Wi-Fi 5, which is what most of us use right now. And the newest one, AX, or Wi-Fi 6, is designed for really crowded places with tons of devices. See? Linking each letter to a standard makes recalling them on the exam so much easier. All right, we have covered the entire journey, from a local message inside your house to a secure web request across the entire globe. Now let's lock in the most important ideas with a really simple, powerful memory anchor. I'm serious. Say this out loud right now. Switches use MAC inside the LAN, routers use IP and NAT to reach the internet. Truly understanding this one single sentence is the dividing line. It's what separates people who are just memorizing words from those who actually understand how a network really works. So these are the core ideas to take away. The LAN is your private house, and it's managed by a switch that speaks in MAC addresses. The router is the gatekeeper that uses IP addresses and that NAT trick to talk to the outside world. Ports are the doors for specific apps, and secure protocols like HTTPS are what keep your data private. This is the foundation of, well, everything. And I'll leave you with a final thought. The principles we talked about today are the bedrock of networking, but the internet is always evolving. With literally billions more smart devices coming online, the Internet of Things, everything from fridges to cars, which of these core rules do you think is going to have to change first? Now you've got the foundation to understand that future. Good luck on your exam.